Hi, it's Dawn from the Red Bank Library, and welcome to Summertime STEM. We're getting ready to celebrate the 4th of July, which makes you think about fireworks, barbecues, and even rockets. And that's what we're going to focus on today. We are going to learn how to build and test a straw rocket. We're going to watch some videos from experts from NASA and the Bearded Science Guy, and we're going to read a great book called Tiny Little Rocket to get you inspired. So I actually made some rockets at home to bring in and show you, so I'll be ready to demonstrate in this activity today. First one I'm going to show you looks like this. And these are the instructions we're going to get from the NASA Junior video. You take a piece of paper, and this one I use actually cardstock paper, so it's actually thicker than your normal paper you get from like printer or computer paper. And that may change the velocity of the trajectory, may not fly as far because the weight of the rocket launcher is actually heavier than usual. But that's how we learn, by testing different materials, and that's what NASA Junior suggests to us, is we test the design of the rocket, how long the nose cone is, and also the design and how many fins we make. This one's fins are made from actually regular, everyday computer paper. And you can see I put it around a pencil, I taped it down, I crushed and pointed the nose cone around the tip of the pencil to make it into a pointed triangle, and taped it all around. It's important to tape it because that way the air will not escape, because we're using the air in our lungs as the force to propel the rocket through the air. So we're going to give this one a try and see how far it goes, and then we're going to keep track a couple more tries too. I'm going to do just one for you today, but while you're doing it at home, it is good to have a couple different trials. So I'm going to stand up here. I'm going to blow it that direction toward the bookcases, so you can see I'm inserting my straw into my rocket, and it almost reaches as far as the bookcase. I'm going to go ahead and stand by it, show you that it reached right over here. Now I have used different styles of rockets, and they have blown further than this, but this is probably pretty much the average distance it goes. Again, it depends exactly how you made your rocket. So we're going to measure it with a ruler and just see how far. 1, 2, 3, 4, 5, oh, not bad, 6, 7 feet. I had one that went yesterday 13 feet, but that is a pretty good distance to get from just a piece of paper and your air in your lungs. Once you download the instructions from the NASA Junior site, it also gives you a form like this, and this is a straw rocket data log where you can keep track of the results of your experiments and of your tries. So one of the things they wanted us to do was measure how long the nose cone was. So you could do that with a ruler. I use a centimeter ruler because an inch one's a little bit big, but you can do it with both. And then you record the distance. And we record 7 feet, this first box, of how far it went. Notice there are 5 boxes, so you would try 5 different times to see the distance the rocket flew. And that would give you an average of the distance and the velocity. The velocity is harder for us to measure because that's the actual speed the rocket goes. And you need a really quick stopwatch to time that and figure that all out. But there's a section here for notes. Like I might want to say, this rocket may not work as well because it's been used 10 times already. Please check to make sure there's no holes or air leakages anyplace. You may want to put a note that this one's made from cardstock all around, or this one is made with construction paper, and keep a note and see what differences you notice and which ones have better results. So now we're going to get ready to watch NASA Junior video so you can learn how to make your own straw rocket like that and what actually causes it to work scientifically. Thanks for joining us, and just hold on a moment. Welcome back. We're going to listen to NASA Junior's video about how to create our own straw rocket and what causes it to propel and have a trajectory. After that, for those of you who really want a challenge, we're going to take a look at another video of how to make a rocket using 1/2 inch PVC pipe, a soda bottle, some threaded elbows, electrical tape, and some other details. Stay tuned. Here we go.
Today we're going to build and launch a small rocket and then try to improve our design. NASA uses rockets to launch satellites in
Hi, I just love those two videos. I think I'm going to try both, the paper rocket and the PVC rocket. It looks like lots of fun, and I'm in luck because I live next door to a park that has a big grassy field that I can practice launching my rocket safely. Don't forget to wear eyewear, sunglasses, or goggles to protect your eyes in case something should accidentally fly in the wrong direction. As you can see from the background in this video, you can tell I'm in the children's room of the Red Bank Public Library, where luckily I can access some great books to share with you, and I found the perfect one to share for this STEM workshop. It is called Tiny Little Rocket. You see lots of details here of the fuselage of the rocket. And let's get started. It is written by Richard Collingridge. He's actually the author and the illustrator of the book. It means he did the words and the pictures in the story for us. Over a little bit so you can see it. There's a tiny little rocket that will take you to the stars. It only flies there once a year, but zips you out past Mars. Its fins are solid silver with a door made out of gold. You can tell where it's leaving from down here. We recognize that as the planet Earth. There's a cozy pilot seat inside for a person, young or old. It whizzes you out to deepest space while you hold on to the handle. And there you'll find the golden sun, our ever-burning candle. And take a look at that picture. You can tell that the sun is super, super hot. But I bet many of you already knew that. You hang there for a moment while the rocket hums and clicks. The sunlight gleams on silver wings. Behind you, something ticks. Let's see if we can read on to find out what that something is. You see a purple lever that blares out, "Pull me now." The booster rockets all go whoosh. You quietly whisper, "Wow." The little rocket zooms again. A huge rock fills the screen. A meteor. It's going to hit. You give a mighty scream. It bops the rocket in the face and knocks you into outer space. Round and round the stars do roll. Quick, you better take control. This emergency. I hope everything's going to be all right. You turn the wheel. You steer the ship. Your eyes go wide to see. And like a gorgeous fish of steel in space, you're swimming free. And there's the rocket. You dive back through our system, one planet, one by one. The tiny rocket zooms you home to the third one from the sun. And the Earth is number 3. There's a button on the rocket that winks just by your head. And you have to press that button when it turns from green to red. You press the button with your hand and a banner is unfurled, a big sign. It stretches from the moon to Mars saying, "Happy birthday, world." Happy birthday, Earth. But just how old are you? Everybody's birthday is measured in the same way, by how many times the Earth has gone round the sun. If you are 4 years old, then you have been around the sun 4 times already. If you are 10, then you have been around 10 times. In a way, the most important birthday of all is the Earth's own birthday. Nobody knows exactly when the Earth's first day was. However, most scientists nowadays agree that the Earth is approximately 4.5 billion years old. Millions of people all around the planet celebrate New Year's Day as the Earth's official birthday. So if you were to make a birthday cake for the Earth, it would take roughly 4.5 billion candles. But perhaps you don't need to. In the old days, light was measured in candle power. The sun, our ever-burning candle, puts out the equivalent of 6.84 octillion candles. I can't even imagine how big, strong, hot, and powerful that is. No need for a birthday cake for the Earth while the sun shines every day. And that is the story of Tiny Little Rocket. While I know that your rocket will not fly as far as outer space, I hope you have fun designing it. And if you're listening to this, the code word for this session is rocket. If that doesn't work, try rockets with a plural. I think we made it singular, but double check. And we hope to see you again soon. Have a great 4th of July. Relax, celebrate, and we'll see you for STEM next week at the library. Bye-bye.
Let's no longer provide.